This year in physics, we've learned a lot, and remembering it all to take the final is most likely going to be awful. For that reason, I'm making this video to help us review. In the beginning of the year, we talked about frames of reference and how they affect what our brains and eyes observe, or at least what they think they observe. We then learned about the difference between inertial and non-inertial reference frames. However, these concepts are more confusing than they seem, and when you're given a situation where you must draw force diagrams to explain the situation using physics terminology, it's important to keep these different kinds of reference frames separate. First, let's define what an inertial and non-inertial reference frame is. An inertial reference frame is a frame of reference that describes time and space homogeneously, meaning that the objects in that frame are in a uniform state. And in an inertial reference frame, the law of inertia must always be correct. In a non-inertial reference frame, that's not true, because a non-inertial reference frame is a frame of reference that is undergoing acceleration with respect to other frames around it. Thus, the law of inertia is not correct in a non-inertial reference frame. So let's look at some examples. An observer out in space would be in a non-inertial reference frame compared to the Earth because he or she would be able to see the Earth moving relative to him staying still. Contrastingly, we are in an inertial reference frame right now. We can't see the Earth moving because we are accelerating at the exact same rate as the Earth. So another example. You're in a car traveling at a constant speed of 60 miles an hour. You are in an inertial reference frame because you are not accelerating in relation to anything around you. If you were merging onto the highway and accelerating, you would be in a non-inertial reference frame because you would be accelerating in relation to the frames of other people and objects around you. So now let's look at reference frames in a more general manner. You are walking around downtown somewhere and there are a bunch of people around you and your best friend is waiting at the end of the street because you're supposed to hang out. Who or what can and cannot see you moving? Your clothing cannot see you moving, but not for the most obvious reason, not because it doesn't have eyes. Your clothing can't see you moving because your clothing is in the same exact reference frame as you are. Your clothing is in an inertial reference frame and is moving in a motion uniform to the motion of your body, which is why it looks to your clothing as if you're not moving at all. But your friend who's waiting down the street for you can see you moving because you are accelerating towards him, and he's in a non-inertial reference frame. So I really hope this cleared up inertial reference frames versus non-inertial reference frames. I know they're confusing, but it's really important to know the difference between them and know how to apply the difference, because otherwise kinematics and everything else becomes meaningless.